So we need to find the Maclaurin series of cosine of x, and we need to find the radius of this series without using any known power or Maclaurin series besides geometric. So the Maclaurin series of a function f of x is given by f of x equals f of 0 plus f prime of 0 times x plus the second order derivative of f of 0 plus times x squared over 2 factorial plus the third order derivative of f of 0 times x cubed over 3 factorial, and so on. In our case, f of x equals cosine of x. So let's compute the first few derivatives of a cosine of x. So f of 0 equals 1, then f prime of 0 equals 0, the second order derivative of f of 0 equals -1, the third order derivative of f of 0 equals 0, and the fourth order derivative of f of 0 equals 1. So let's use it. We get that the Maclaurin series is cosine of x equals 1 minus 1 minus x squared over 2 factorial plus x to the fourth power over 4 factorial, and so on, which equals 1 plus -1 times x to the power of 2 minus 1 over 2 factorial plus -1 squared times x to the power of 2 times 2 over 4 factorial, and so on. And so on. So this means that cosine of x equals the sum where n goes from 0 to infinity of -1 to the power of n times x to the power of 2n over 2n factorial. So this is the required, let me highlight it, the required Maclaurin series. Well, now let's use a ratio test for radius of convergence. So the limit of -1 to the power of n plus 1 times x to the power of 2 times n plus 1 over 2 times n plus 1 factorial over -1 to the power of n times x to the power of 2n over 2n factorial. So, and n approaches infinity. This equals the limit of the absolute value of x to the power of 2n plus 2 over x to the power of 2n times 2n factorial over 2n plus 2 factorial, and n approaches infinity. So this equals x squared times limit of 2n factorial over 2n plus 2 times 2n plus 1 times 2n factorial. So this equals x squared times the limit of the absolute value of 1 over 2n plus 2 times 2n plus 1 where n approaches infinity, and this equals 0, which is less than 1. So that means that the series converges independently of the value of x. So the radius of the series is infinity. So radius is infinity. Well, now let's do part B. In part B, we need to find exactly the series of cosine of -2x. So part B, f of x equals cosine of negative 2x. First we need to find the first few derivatives. We get that f prime of x equals 2 times sine of negative 2x. The second order derivative of f of x equals negative 2 squared times cosine of negative 2x. Then the third order derivative of f of x equals negative 2 cubed times sine of negative 2x. And finally, the fourth order derivative of f of x equals 2 to the fourth power times cosine of negative 2x. So now we get that f of 0 equals 1, f prime of 0 equals 0, the second order derivative of 0 equals negative 2 squared, the third order derivative of 0 equals 0, and the fourth order derivative of 0 equals 2 to the power of 4. So the Maclaurin series is, let me write it down, cosine of negative 2x equals 1 minus 2 squared times x squared over 2 factorial plus 2 to the fourth power times x to the fourth power over 4 factorial, and so on. So this equals 1 plus negative 1 to the power of 1 times 2 to the power of 2 times x to the power of 2 times 1 over 2 factorial plus negative 1 squared times 2 to the power of 2 times 2 times x to the power of 2 times 2 over 4 factorial, and so on. So we get that cosine of negative 2x equals the sum of from n equals 0 to infinity of negative 1 to the power of n times 2 to the power of 2n times x to the power of 2n over 2n factorial. And this is our